The following content is for entertainment and educational purposes only. It does not constitute means for diagnosis, healthcare advice, nor treatment. Make use of a qualified healthcare professional for such purposes.
So something very important. This is an important fact. Okay, guys? We use inferential statistics to understand whether any differences between the groups that we analyze, whether they're significant. Okay, that's something very important. You should note that down and memorize it. Okay, we use inferential statistics to understand whether any differences between groups are significant. When we're using an interval ratio scale, we're using parametric statistics. Okay, so as you can see here, interval scale is when you have no true zero. You do have meaningful differences between the numbers. And the numbers are also possible. So Likert scale or Likert scale is an example of that. We assume that there's equal intervals between like strongly agree, neutral, and so forth. A ratio scale is when we have a true zero, and that means that zero actually means nothing. Okay, so an example of that would be here we've got recall percent. So when you remember, so like say you're trying to remember a string of numbers. If you get a score of 0, that means you remember no numbers, nothing, right? So 0 really means nothing on a ratio scale. And the mean, standard deviation, standard error are the most meaningful descriptive statistics to summarize interval ratio data. And we use inferential statistics like a t-test or an ANOVA, which we'll be talking about today a little bit, to determine if there are statistically significant differences between groups. Again, that's that important fact that you guys need to know. Okay, so the experimental design informs which statistic we're going to use, right? So for today, I was going to use an example of a researcher looking at math test scores. So I'm going to write that up here to remind us all. So in this case, right, the test scores would be the dependent variable. So we've got 3 experimental designs that we're going to talk about today. A two-group comparison. That's when you have one factor, and you have 2 levels, which makes 2 groups. So the example with the math test scores, right, in a 2-group comparison, let's say we wanted to see how time pressure had an effect on math test scores. Let's say you had some one group, you let them have 1 minute per question, and another group, you let them have 5 minutes per question as they were taking the test. So you'd have a low and a high time pressure. That would just be 2 groups, right? The low group and the high group. That's a 2-group comparison. And you would use the t-test to analyze that. We also have the multi-group comparison where you have, again, only one factor, but now you have 3 or more levels. So the example with the math test scores, let's say we wanted to know if you were teaching the math 3 different ways. Let's say some people learned it the traditional way, some people learned it the Common Core method, and some people got a hybrid of both of those methods, right? That's 1, 2, 3 groups. Because we have 3 or more, we're in a multi-group comparison, we would use a one-way ANOVA, okay? And then with a multifactorial design, you have 2 factors, and those factors can have multiple levels as well. So let's say we combine both of these into one experiment. And we now are looking at time pressure and method, all in the same experiment. That's a multifactorial design, and you use a two-way method for that, okay? And we're gonna talk a little bit more about this going forward. So here's another way to sort of visualize that exact same information, right? So in a two-group comparison, you have the two groups, right? No time pressure, high time pressure, and you would use a t-test. Say again? Multi-group comparison, that's right. So you have three or more groups, right? 1, 2, 3, and you would use the one-way ANOVA for that one. Let's look at the next one. Who knows what the other one is that I haven't shown you yet? Multifactorial, there's somebody, that's right. Okay, so this is a visualization of the multifactorial. So you've got actually 6 groups of people, right? You have 2 levels in one factor and 3 levels in the other. And so that makes 6 total groups, right? So you've got the high time pressure group, and in that high time pressure group, you have it divided into 3 with the different teaching methods. And then again, you have the same thing with the no pressure group where you still have the 3 teaching methods. So let's see, what about these? I'm going to, so I've got 2 examples here, and I want us to figure out what experimental designs each of these is. So the first one is, we're going to go with experiment A first. Participants completed an anagram. That's when you get like a string of letters and someone asks you, how many words can you make out of this? Okay, so their participants were asked to do that with either a pen, they were given a pen that either they customized with some personal stickers that showed, you know, I don't know what stuff they were into, you know, like Pokemon or sports team or whatever. So they were able to either customize the pen, or they were given a pen that somebody else customized, or they were given a pen with nothing on it at all, just a plain boring pen. Okay, let's see. First, let's walk through the process, right? The thought process of how we figure out the experimental design. What I like to do is first write down the dependent variable, which is what is being measured. Okay. What are they measuring? What are we measuring in this situation?
How many words you can use without the anagram?
That's right. And do you guys know what level of measurement that is? That nominal, ordinal, interval, or ratio? It's not nominal because we're doing a number of words. So nominal is the one where it's a category, like if you were thinking about types of movies, you know, like horror, comedy, drama, something like that. So this one is actually going to be ratio. And that's because if we have 0 words, does that mean no words? All right, the next thing we're going to figure out is what are the independent variables? What's the independent variable, or maybe there's more than one? I don't know. What is it for this one?
Just type of pen.
Type of pen. That's it. Is there only one independent variable there?
No, there's 3.
There are 3 levels. So there's not 3 actual independent variables, there's 3 levels. And the levels are the 3 types of pen, right? So we've got customized, and we've got somebody else did it, customized it, and then we've got a generic pen. How many levels is that? 3. So does that tell us anything about our experimental design? Yeah. Multi-group comparison. Multi-group comparison. That's right. So we've got 3 groups. We've got one factor, one independent variable, and we've got 3 levels. So that's the 1, 3 plus, right? So that is a what type of test? One-way ANOVA. One-way ANOVA. All right, let's look at the B one. Participants used a mindfulness app to complete a 1-minute, 5-minute, or 10-minute meditation. And they did it either 1 time a day or 1 time per week. That was the frequency. And then they took this Maslow burnout inventory, which is a survey that measured burnout. So again, what were we measuring? Anybody? Okay, so the survey is how we're getting the information. So that means our dependent variable is the burnout, right? Their score on the survey. All right, what about the independent variable? What is the researcher manipulating?
The time and frequency.
Time and frequency, that's exactly right. How many independent variables is that? How many is that, guys? 2? I see 2. So yeah, so we have 2 independent variables. And then what is this? We've got time, right? But we've got 3 different times. What is that? What?
Levels.
That's right. Those are the levels of the variable, okay? And then same here, we've got frequency. We've got 2 levels of that one, okay? So we've got 2 factors, and one of them has 2 levels, and one of them has 3 levels. What experimental design is this? Multifactorial, that's what it is. You guys are right, multifactorial. So we've got more than one factor, multiple factors. This one again was multi-group. Oh, and if we have a multifactorial, what kind of test are we going to use?
Two-way ANOVA.
Two-way ANOVA, you got it, guys. This is an SPSS output, as you can see. In experimental psychology, a lot of times we analyze our data using computers. So this is just a descriptive statistics table. And you can see here, we've got this factor of face. There's actually 2 of them here. And then there's all these variables that they're analyzing for these 2 faces. And then if you look at the top of the columns, it tells you what these numbers are. It tells you this column is n statistic. What do you guys think that means? What number of people? Yeah, number of people, that's your n, right? So how many people are in the group or the experiment? How about here? You've got 2 columns under mean, right? One says statistic and one says standard error. So I'll just tell you guys, this one is the mean, the actual mean, and this one is the standard error of them, okay? And then you've got, so that would be your S, if you were reporting your S. And then this one's your standard deviation. So here I've sort of highlighted to show you guys, and again, this is really important for your paper because you're going to need to know how to report, like if whatever experiment you're going to be reporting, how to say a t-test, how you would report that, okay? So it's the same table, right? And what we're reporting is freedom, which is n-1, right? And then you're going to put your t-value, which you're going to see this on the next slide, right? And then you're going to put your p-value. On this one, on your descriptive statistics table, you're going to report your mean and your standard deviation. Sometimes you're going to be asked to report the standard error. If you were going to do standard error, you just change the SD to SE and you report the right number, right? So for standard error, you report this column. For standard deviation, you report the number. Yes.
Is there should we always be rounding it up? Like, so it's 0.1451, but would we go ahead and round that up?
So I mean, I've got 3, significant digits here, right? So you can like you do see this to 3 digits sometimes, and this and this. I mean, you would round it to 2 decimals here, and then if you had, and then round it to